Okay, today we're going to talk about two-sample hypothesis tests. Before we had looked at taking a single sample and comparing that sample mean to some predetermined number, a hypothesized value, and trying to make a conclusion about the population from which that sample was drawn, and how that population mean stacked up against that predetermined number. This week, or in this session, rather than comparing to a predetermined number, we're going to be comparing the mean of one group with the mean of another group. So we could see if there are differences, let's say, between males versus females, or between athletic students versus non-athletic students, or foreign students and domestic students, whatever two groups we wanted to compare. If we're working with means, what we're actually going to do for our alternative hypothesis is say that the population mean for group 1 minus the population mean for group 2. We subtract that, and the difference, if we're just looking for a difference, would be not equal to 0. We could also presuppose a particular direction to that difference. We might think that the mean for the first group should be larger than the mean for the second group, so we'd have a greater than symbol here. Or if we thought that the mean for the first group was lower than the second, then we'd have a less than symbol there. Regardless, our alternative hypothesis is always going to be that the difference between those group means is equal to 0. And notice I've got the symbology there for the population mean. We're going to be working with a sample and trying to make an inference or a conclusion then about that population. The data file that I've got here deals with children, and they took 3 different groups of children. We're only going to be concerned with 2 of those groups for now. These children were experiencing cough symptoms, having trouble trying to sleep, and they gave one group of children honey. They gave another group of children dextromethorphan or cough syrup. That's the DM column there. And then they had a control group that didn't actually get anything. And the values that we came up with were measuring the parents' perceptions of the improvement in the child's symptoms after taking that medication or treatment. So we're going to see if the honey group actually produces better improvement than the cough syrup group. We're going to click on our stat button, and this is quantitative data, and we have, just to show you here, we have 35 observations in our honey group and 33 observations in the cough syrup group. So that means that we are going to use a z-test. So we'll go to stat, z-stats. We've got 2 different samples now, so we'll choose this 2-sample test. We have the raw data here. We'll use that. And all we need to do here is choose the honey column for group 1, our DM or cough syrup column for group 2. And we want to make sure that our hypotheses are set up the way we need them. And in this particular case, since we believe that the honey group will have more improvement than the cough syrup group, we're going to say that the mean for group 1 minus the mean for group 2 is greater than 0. We'll click compute to run our test, and we can see that there is a significant difference here. We can reject the null because we have a p-value of 0.0007, which is less than 0.05. The sample mean that it shows us here is actually the mean difference, mean from group 1 minus the mean from group 2. So this is saying that the improvement in the symptoms was about 2.4 points higher for the honey group than for the cough syrup group. The next problem that I want to take a look at is actually problem 8.40 on page 447 in your book. And the data set that we're going to look at is called REDLIT. Deals with the installation of red light cameras at different intersections. and they measured the average number of accidents occurring at those intersections before installation of the red light cameras and the average number of accidents during the same time periods after the installation of those red light cameras. We have 13 different intersections that we looked at. We have quantitative data, so we know this is going to be a t-test. But one other thing that this data is indicative of is this is what we call a paired test. Whenever we have a before and an after group, we have two different observations or measurements based on the same subjects. Our subjects here are the intersections. We have a before measurement and an after measurement for each intersection. So that is a paired sample. We have a pair of observations for each of our subjects. So we'll go to stat, t-stats, and paired. And in fact, whenever we have a paired sample, we have to go to t-stats even if we have more than 30 observations in each group. Our sample 1 was in the before column. Sample 2 is after. We want to see if before there were more accidents, so the mean before should be greater than the mean after. So we're looking for greater than 0. We click compute, and here again we see that we can reject the null. We have a p-value of 0.0055, which is less than 0.5, and our sample difference tells us that the mean number of accidents was reduced by approximately 1 per intersection over that time period. The last example that I want to talk about in this particular video deals with a proportion test, and it comes from page 453, problem 8.50. It's kind of a different situation here. They did a survey and they asked Republicans and Democrats what their favorite food was on the barbecue, and they found that 662 out of 1,250 Democrats chose steak, and 586 out of 930 Republicans chose steak. Well, this is a categorical variable. What food do you like? So we go to proportion stats, to sample. Now we just have summary information. And we'll put in the data from our 2 samples. We had 662 out of 1,250 observations in group 1 for the Democrats, 586 out of 930 Republicans. We're looking at proportions here rather than means, and we're just testing to see if there's a difference. So not equal to is fine for our hypothesis. We click compute. Once again, we see that we can reject the null. There is a significant difference between the proportion of Democrats versus the proportion of Republicans who prefer steak. That difference is right about 10%. And so if they can't even just agree on what food to cook on the barbecue, how are they going to agree on major policy decisions?